Okay, I wanted to look closer at number 19 here, largely because my solution was incorrect the first time. So when you're looking at y equals 2 cotangent of 2x, what is really helpful is to realize that cotangent is simply y equals 2 times 1 over the tangent of 2x. And so that will help us to have a better understanding of what this graph looks like if we can first look at the tangent of 2x. So let's come down here and take a look at the tangent of 2x. And so if we graph the tangent of 2x, well, actually, we'll just go ahead and do 2. Well, no, let's just do tangent of 2x. And so what we learned about tangent of 2x is that the period of tangent is usually pi, and so that means our tangent, our period, is just going to be pi over 2. And so we'll let our x scale be just pi over 4 to help. And so that's going to give us 3 pi over 4 and pi and whatnot. And then what happens with the tangent graph is there are some significant points. The significant points is, when is tangent 0? When is tangent undefined? And then when is tangent going to equal 1? And we'll get to that in a second. So for this problem, tangent is 0 when the x value is 0. And so if you remember, when we're looking at our unit square for 0 degrees, our coordinate on the unit circle is 1, 0. For 90 degrees, it's 0, 1. And then 180 or pi, it's -1, 0. And then for 270, it is 0, -1. So for tangent is always just y over x. And so at 0 degrees, tangent just equals 0. And so for this graph, we know that tangent is 0 at that one. But at pi over 2, which in this case would be pi over 4, right? If we put pi over 4 into that, you get pi over 2. So at pi over 4, that is where our x value is 0, which means tangent is undefined. And so that's where our asymptotes live. So and then it's going to equal at -pi over 4 as well. And so where you end up is a graph that looks like this, where you have these asymptotes at 0, at -pi over 4 and pi over 4, and then 3 pi over 4, and then 5 pi over 4, and then our tangent graph in between. And the way that it behaves is that the tangent ends up looking like this in between those. And so in between each of those, your tangent looks like this. So where these asymptotes happen, notice for the asymptotes, as it gets closer to the asymptote to the right, it is getting really, really large, and as it gets asymptote to the left, it's getting very, very, very negative as well. But it's happening so that it's trending closer and closer to the asymptote. So let's look at cotangent back up here. So when we're taking a look at this one, again, we're going to do the same thing. Our x scale is going to be pi over 4, because our period is pi over 2, pi divided by 2. Remember, the tangent is pi divided by b, whatever is in front of the x. And then for sine and cosine, it's 2 pi. Y scale, we're just going to be 1. We don't do a min and max on these. So what happens is this one is undefined when tangent is 0. So back down here, when was tangent equal to 0? At 0, pi over 2, pi, and whatnot. So that means we know for a cotangent graph, the asymptotes happen when the tangent graph equals 0. So we just shift over our asymptotes. So the asymptote should look like this. Now, the part where we got it backwards when we were graphing this is what happens as it approaches 0. Well, let's look at our tangent graph. As tangent approaches 0, as it approaches it from the right here, as this approaches 0 right here, tangent, it gets closer and closer and closer to 0. And so 1 over that, as it is getting larger and larger and larger and larger. And so for the cotangent, as the cotangent approaches 0 from the right, it's getting larger and larger and larger and larger. And so it means it actually starts up here. And then what happens when it approaches pi over 2? Well, as it approaches pi over 2, the tangent graph is getting closer and closer and closer to 0 as well. That's this section right here. It's approaching 0, but it's approaching from the left, which means it's approaching from a negative. And so what happens close to this one, it's actually very negative. It's becoming more and more negative. And so that's why the cotangent graph is reversed. And then we know because of this 2, it's going to equal 1 halfway in between those, right? At pi, usually it's pi over 4. In this case, it's going to be pi over 8. And so that's where our halfway in between before it gets to the 0 is at the 2 instead of the 1 because of this 2 in front of there. So the graph looks something like this. It's hard, really, these are really hard to draw. But the key takeaway is it looks just like the tangent graph, except that it is in reverse. Right, the tangent goes up and to the right, the cotangent goes up and to the left. And it shifts over your period. The asymptotes all shift over by half the period as you go through. So if you can graph the tangent, you just shift it over half the period, and then you basically do it in the opposite direction, and you're going to get your cotangent graph. And so that's how you graph cotangent of a function.